In the last lesson, we talked about how to find all of the factors if you were given one of the factors. So I said something like, x plus 1 is a factor of this thing. Find the rest of them. And we used synthetic division and got the depressed polynomial and so on. Now, that was nice that I told you that, but a lot of times you're not told that, okay? You're just given a polynomial and you just have to figure out what the zeros are. So that's where this theorem is going to come in. It's called the rational zero theorem. And it's a way to find all the possible rational zeros. Now, it doesn't guarantee that these are all zeros, they're just possibilities. And the way we do that is this P over Q. P are the factors of the constant term, and Q is the factor of the leading coefficient. So let me show you how this works. So all of the possible rational zeros now, again, these are possible rational zeros. It does not account for irrational zeros or complex ones. So there's some limitations to this. We take P over Q. So P is the constant term, and we want to list all of the factors of that. So factors of 12 are 1 and 12, but they could be positive or negative. So plus or minus 1 and plus or minus 12. 2 and 6, so plus or minus 2, plus or minus 6, and 3 or 4. I did not leave enough room there. So those are all of the factors of the constant term. And then we have to divide by the factors of the leading coefficient. Now, the leading coefficient is just 1. So we have to divide all of those by plus or minus 1, which doesn't change anything. So you like it when this number is 1 because it makes the problem easier. So that's it. Those are our possible rational zeros. Okay. Again, not all of them are going to be zeros, but one of them might be. All right, let's check the next problem. We want to list all of the possible rational zeros of this. So we're going to start with the factors of 16. So plus or minus 1, 2, 4, 8, and 16. And then we have to divide that by all of the factors of 4. So the factors of 4 are 1, 2, and 4. And now we actually have to do this division. So here's how this works. You take everything on top and divide it by plus or minus 1. Now, that's not going to change anything. So all 5 of those numbers on top, it divided by 1, those don't change. So just 1, 2, 4, 8, and 16. Then we take all of the numbers on top and divide them by 2. So we take 1 divided by 2, which is 1/2. 2 divided by 2, which is 1. I already listed that, so don't list it again. 4 divided by 2 is 2. We already have that one. 8 divided by 2 is 4. We already have that one. And 16 divided by 2 is 8. Okay, so don't list the ones that you already have. And now we have to take everything and divide it by 4. So 1 divided by 4 is 1/4. 2 divided by 4 is 1/2. We already have that. 4 divided by 4, we already have that. 8 divided by 4, we have that. And 16 divided by 4. Okay, so this is our list of possible rational zeros. Let's do one more example, and then we'll put it all together in the last video. We want to list all of the possible rational zeros of this function. So we're going to take the factors of 10, which are 1, 2, 5, and 10, and divide them by the factors of 3, which is 1 and 3. So we need to take all 4 numbers on top and divide them by 1, which fortunately that doesn't change anything. And then we take all 4 numbers on top and divide them by 3. So we get 1/3, 2/3, 5/3, and 10/3. So those are all possible zeros. In the next video, I'll show you how to use these numbers to find all the zeros.